So this is our lesson 4 on chapter 6, and today we're going to look at rectangles. When we started off this chapter, we were just looking at quadrilaterals and what are the rules and theorems for quadrilaterals. Then we looked at parallelograms and tests for parallelograms, and now we're going to look at rectangles and some of the rules that we need to follow to determine whether something's a rectangle or not, or to solve for an unknown with a rectangle. So the special things we need to remember is that if we have a rectangle, we have 4 right angles. That's one thing. So all the angles in that parallelogram, that rectangle, are going to be equal to 90 degrees. And then also, opposite sides are parallel and congruent. And you can kind of see that down here. Parallel with these little arrows, congruent, 2 and 2, 1 and 1. So that's true. And then you see the square here. That tells us their right angles are 90 degrees. Okay, then also we know that consecutive angles are supplementary, which means they're equal to 180 degrees. Okay, so if we add these two angles together, they're going to be 180 degrees. And then also that diagonals bisect. So if we have a diagonal from A to D and B to C, they dissect. Okay, so these they cut in half, so 3 and 3, 4 and 4. They're equal. Each side is equal to the other. Okay, now there are a couple theorems that we need to look at. Okay, and let's look at the first one. A parallelogram is a rectangle if its diagonals are congruent. Okay, so that's kind of the thing we just said. So if these are congruent, if its diagonals are congruent, then we know that it's a parallelogram. So if AD equals BC or CB, then we know that it's a rectangle. But then we can go the other way, and really this is the converse of the opposite. It says if diagonals are congruent, then a parallelogram is a rectangle. So if we don't know anything about this, but then we measure these and we see that they are the same or congruent, then we know we have a rectangle. So those are kind of some of the rules that we need to remember. So let's use some of those ideas, and I have this color-coded here, and I'll show you why in a minute. So if we were going to use algebra and try to figure out some angles and solve for an x, okay, so here we have this triangle JKLM, and I got it color-coded. I'll explain it in a minute. And it says, is it a rectangle so we have to assume this is a rectangle, and it's also telling us that the measure of angle KJL is equal to this, okay, and then 2x plus 4, and then we say the measure of JLK is equal to 7x plus 5. So we got the angle here for KJL, we just call that A, and then JLK, we'll call that B. Okay. So it wants us to figure out what x is for this problem. And it gives us these two measurements of algebra, 7x plus 5 for JLK for B, and KJL is 2x plus 4. And you might look at this and say, boy, if I didn't have these lines in here, I'd know that this vertices J is 90 and this vertices K is 90, and if B was across from A, I'd know together that they equal 90. But here it's not so easy. Okay, so I colored yellow here. That's our first KJL, and it also gives us another truth for this, and this is the idea. In this problem it tells us the measure of angle MLK is 90. Okay, and we can kind of assume that. So if we're saying it's a rectangle, right? So we should know that this angle, MLK, is 90 degrees. So we're going to write that in. Okay, and you might say, doesn't help us, right? Because it gives us B, okay, but it doesn't give us A. Okay? So, and we could say, right, MJK is 90, but again, we would need this angle over here to figure out that these equal to 90. Okay, but we're going to use something here that one of our old rules, and it's something called alternate interior angles. Okay, let me write that down. Alternate interior angles. This is something we haven't used for a while. And if you remember what that means, it really says that if we have two parallel lines and a line that crosses it, then we know that this angle is equal to this angle, right? Okay, so we can almost say, right, so if we just look at this angle, and this angle right here, if we just color it in a different color, let me pause for. So if we're really thinking about this, we could say, if we had this angle, okay, we could come back and think like, so if you had pink here, with the wrong color, we'll make it black. So if we have the second angle, let me just mark it here. Okay. So if we have JLM, and then the measure of that plus the measure of JLK, that would equal to 90 degrees, right? So we have that right there. Measure of JLM and the measure of JLK, we know those should be equal to 90, right? And we can use the alternate interior angle to know that this angle, the alternate interior angle A, is equal to that. So we could take this statement, which is, let me write it down here. So we're going to write it right here. So we're going to say the measure of angle JLM plus the measure of angle JLK is equal to 90. But then JLM is also equal to KJL. And we know what KJL is, 2x plus 4. So we're just going to plug that in. Measure of KJL, because it is the same as JLM, plus the measure of JLK, this one here, and we know what that is, and we'll just leave it for now. They are equal to 90. So since we can use that alternate interior angle, we can really say KJL is plus, what is it, KL, or JLK, is, when you add those two together, they're equal to 90. So let's write this down here. Give me a second, I'm going to pause. Okay, so then if we take this JLM, we're going to replace that, right, with KJL. We know what that is, 2x plus 4. Move that up a little bit. And then we're going to add it to measure JLK. We have it right here, 7x plus 5. That's all equal to 90. We're going to collect these like terms. 9x plus 9 equals 90 minus 9 is 81. So 81 equals 9x divided by 9. X equals 9. Okay, so that's an example of how you can solve that. So let me show you one more with coordinate. I'm going to pause it here and let me get everything ready, and then we'll be back on this video. So let's look at one more thing here, how to use coordinate geometry to solve rectangles. So here it gives us this quadrilateral, PQRS. It has the points P is negative 5, 3, Q is 1, negative 1, R is negative 1, negative 4, and S is negative 7, 0. And it wants to know, is the quadrilateral a rectangle? Okay. So how we're going to do that first step, we're going to put in a coordinate system. Then we're going to use the distance formula. We're going to run it through all the points and see what they're all equal to, the distances of each line, and see if the opposites are equal to each other. Then we're going to figure out the diagonals and see if they're equal to each other. So let me kind of show you this here. So I got the triangle. I have the quadrilateral, and what we really need to do is to just plug in the points that we have for each line and see what they all equal to, their distances. We're going to use the distance formula. Let me pause this. I'll do PQ. So there's the first one. So I take the points of P and Q, put them in here. I get 36 for X, 16 for Y, and then in the end I get the square root of 52. So that gives me PQ. So now I'm going to do PS, this one going down here. So let me put these numbers in, I'll pause the video, and then we'll get back to it. Okay, so I did the math here. You notice before I had 7 here, it's -7. But so then you do the math here, -7 minus -5, you get 4. And then when you square it all, then here you get 9 when you square it all, you get square root of 13. Okay, so now we're going to check SR. We're going to hope that SR is equal to square root of 52. So let me plug it in, we're going to pause, and then we'll get back to it. And I'll do this one with you. And so we got -1 minus 7, -7. So we're going to change the sign, and we're going to add. So -1 plus 7 is going to be 6 squared. It's going to be 36 down here. Okay, and then we're going to have -4 minus 6, 4. So that's 16. 36 plus 16 is going to be the square root of 52. So they're good. That's good. And then if we just do QR, let's move that number on too. We pause. So again, we'll do this one together. So we got QR here. So we got -1 minus 1. So again, we're going to change the sign and we're going to add. So it's going to be -2 squared. It's going to be 4. And then we're going to add it to -4 minus a 1. So then it's going to be, we're going to add, change the sign and add. So it's going to be 3 squared. It's going to be 9. So 9 plus 4 is the square root of 13. They match. They match. That's good. We got the first thing done. So then we just need to take and figure out these diagonals and see if they are the same as well. So I'm going to do this up here. I'll put these points up here. Let me pause again, and then we'll be done with these notes. So here's kind of our last step. We just want to check these diagonals. P to R, S to Q. We got these right here. We plugged in the numbers, or I did. So we got -1 plus, or minus a -5, so we change the sign and we add. -1 plus 5 is 4, and the squared 16. And then here we're going to change these. This is -4 minus 3. We're going to change the sign and add. So it's -7 squared. It's going to be 49. That's going to give us the square root of 65. So now we just need this to be square root of 65, and we're good. So we're going to have, we have 1 minus a -7, so we change the sign and we add. It's going to be 8 squared. That's 64. And then it's going to be -1 minus 0. It's going to be 1 squared 1. So it's going to be the square root of 65. So that's good. So here we've compared the sides are the same. So PQ is equal to square root of 65. SR is equal to, the square root of 52 PQ. And then SR is equal to the square root of 52. They are congruent. And then we also have QR, and that's equal to square root of 13. And then we have PS, and we have square root of 13. So they're good. And then we just do diagonals and figure out what they are, and then we got 65 and 65. And we could even go as far as comparing slope. If they had the same slope, they would be parallel. Same with these ones. But this is 2 possibilities, 2 good ways to check this. That's kind of your notes for today. We'll practice some more in class and see you there.